we go back to the example number 2 after we understand that the example number 3 or n. Now we have to trace as we did previously for the example number 3. Now we trace. Let's trace I equal to 1, I less than n, I times 2. Let's say we put that n equal to 10 here. Okay, if I equal to 1, this is true, right? And 1 times 2 is 2, and I equal to 2, and this true, and this 2 times 2, 4. When I equal to 4 here, true, 4 times 2 is 8, and when I equal to 8 here, and this 8 less than 10, still true, and this 8 times 2, 16, and after that this 16 false. Okay, so this the first round here. This is the first round. You can see that the first round 2, the second round 4, the third round 8, the fourth round is 16. Can you see that the pattern here? It is like this: 2 power of 0, 2 power of 1, 2 power of 2, 2 power of 3, and so on and so forth. And this pattern actually 2 power of k. Can you see this pattern? Now we observe the patterns. Before, for the first round, look like 2 power 0, which is 1. The second round 2 power 1, which is 2. The third round become 2 power 2, which is 4. The fourth round 2 power 3, which is 8. This is the pattern until the stop end here. Then we know here until k here. Okay, this basically we can conclude like this: 2 power of k. So now we're going to estimate the n here, the increase the input size n, but the n is the pattern is 2 power of k here. The changes is k. Start with 0, 1 until the k here. And now based on the example number 3, which is actually the higher order of growth here, and from here we can assume that the algorithm here must be less than O n. Must be less than O n, because the increment here not 1 by 1, because we have 8n here, or maybe 10 here, but we can only execute maybe around 4 times, not 10 times. Okay, so we assume that this is not greater than n, must be less than n. So the a class less than n could be log n. So maybe you can assume this log n here, and also this we can put the log 2k here. We want to estimate the n increase here. So this k basically we can bring back, and that become log 2, and this base 2 equal to log n here. And this actually want to estimate the k increases here. So we can simplify here. This become k equal to log n. So we can estimate that this actually end up with O log n.